Hi, welcome everyone. My name is Gasper and I'm Developer Relations Lead at Oasis Network. Today I'm going to tell you more about Oasis Network, architecture, different ParaTimes, and then we will dive a bit deeper on Emerald, our EVM compatible blockchain, and then I will show you some demos. So let me show you what we will do today. First, we will go through Oasis 101. So that's basically an overview of our network, technology, architecture, right? So you will understand the whole package. And then we will go to Emerald ParaTime, which is our first EVM compatible blockchain. It's just like another EVM blockchain, right? But with our specific parameters and performance and scalability and so on, right? So we will go a bit deeper on that. And at the end, I will show you two demos. So the first one will be developing with Truffle. So if you're familiar with Truffle tool, it's one of the most popular ones, right? I will show you how to deploy, let's say, a smart contract via Truffle on our network, on our testnet. And then I will show you another demo. It will be how to integrate, for example, Band Oracle smart contract using simple tool in browser called Remix, right? So we can use different tools. You can use tools like you prefer, right? There is also Hardhat, but again, it's a matter of choice, right? So let me start with Oasis 101. What is Oasis 101 or our Oasis network technology, right? So I will begin with our architecture. It's pretty important that we distinguish ourselves from the others, right? So this is our unique architecture that Oasis Network, brings to the table to all the developers, right? So when we are talking about blockchain, we have consensus layer, and then we have like second layer, right? We're calling them ParaTimes, but in reality, they're just multiple or let's say parallel runtimes, right? So let me begin with consensus, right? So consensus is crucial to be, robust, to be secured and highly scalable. That's why we want to remove all necessary workload and processing, right, from consensus down to other layers. So to our layer 2 called ParaTime layer, right? And all these computations will be done in separate blockchains, right? So for example, we have Emerald ParaTime, which is our EVM compatible ParaTime, right? We will have all the transactions and all the computation done inside that environment, right? Which is isolated from consensus layer and also from other ParaTimes, right? Even though there is a huge benefit using the whole ecosystem, right? Because we have fast transactions, high scalability because of this architecture, and usually I say, imagine Apple ecosystem, right? Everything works together so smoothly from mobile devices, laptops, coding, right? Everything together makes environment smooth and awesome. And the same, we can call and say the same here at Oasis Network. So ParaTimes will just give additional benefits to our blockchain, right? So we will talk more about these other ParaTimes, Cipher and Parcel, right? But essentially, one is for, let's say, data tokenization and having some computation of encrypted data, and there is another one that can be used for different purposes, right? So we will touch all of them. Now, first, I want to give you some numbers and comparisons to other chains if you want. So just to give you a bit of a feeling where we stand, right? So if we compare our consensus layer, right, we have average block time 6 seconds, right? If you compare that to Ethereum, it's more than half, right? And maybe more compared to Polkadot or Avalanche, right? So just to give you an idea, this is the consensus average block time, right? And since all these ParaTimes from layer 2 are sending batches of confirmations to consensus, gives us the same average block time also on EVM blockchain, right? So this is pretty cool. Now, if you check the finality, right, we have instant finality, so we can trust the transactions immediately, right? That's pretty cool because other networks will need some, minutes or, at least seconds, while we have this instantly, right? So usually I recommend people start using or just try to use one transaction, right, from our Oasis network consensus layer to, for example, Emerald ParaTime, right? You will see how fast and easy it is to do that transaction, right? Now, we're using proof of stake, and you will notice that our layer 1, so basically the Oasis network itself, the consensus, or if you want layer 1 network or blockchain, provides confidentiality, right? So some level of privacy on layer 1. So we don't need other layers, right? But we bring that to the table, from the beginning, right? From scratch, from the bottom, right? So in the layer 1 blockchain. Now, comparing the scalability, you will notice that transactions on our network can scale up to 1,000 transactions per second, right? So even this is a good number, let's say, right? And then we have a number of paratimes on the second layer, right? And now we can have multiple paratimes. Currently, let's say we can scale up to 1,000 paratimes. And if you just multiply these numbers, then you can see how scalable everything become, right? So it's pretty cool, it's awesome, and yeah, I really like that, especially that I can also create my own paratime. So if I'm a developer, if I have a group of developers, we can decide to bring something new to the table with creating a new paratime, right? So we can code a new paratime, right? We will just take a look at paratimes that Oasis team actually developed, right? Okay, so some other features, let's say that we support, is this smart contracts that are could be, right, in two ways, written in two ways. So the one that you're already familiar with is of course Solidity, and this is used on EVM blockchains or Ethereum. We support that on Emerald. And then we have also smart contract support for WebAssembly, right? This is very wanted feature on our Cypher ParaTime. So it's already available. You can test it. It's available on our testnet, so on the Cypher testnet. So I'm inviting you to try it. And yeah, it's pretty awesome feature because if you compare it to others, only Polkadot maybe it's compared to that, right? And of course, we can also provide something that it's not provided on any other chain, like permissioned and permissionless versatility if you want to choose from, right? So by default, let's say we have permissionless, right? Now, to touch a little bit on the Cypher ParaTime. So keep in mind that Cypher was designed to deliver these smart contracts written in Rust and then compile to this WebAssembly, right? So basically we can talk about this WASM, and the most important, I would say, for sure, is this TEE or Trusted Execution Environment, right? Because if you imagine, or if you ever heard about that, this is basically already known term, right? Or principle. When we have, let's say, malicious OS, and we want to have security environment to execute, our, maybe program our code, right, in security environment. But now this is possible on blockchain. So that's why this is so awesome. Cypher enables this TEE on the blockchain, right? So we have now Cypher ParaTime, which is like a separate blockchain, right? Isolated from consensus and other paratimes, and we can perform that in a secure environment on our cipher ParaTime. So when we talk about confidentiality, we can talk about private transactions and private states, right? You will notice that sometimes we just want to present, okay, this is a black box, whatever goes in, it's processed and so on, but we don't want to expose who owns some address or who is the owner of something, right? So we keep that private, and this is confidential inside the ParaTime cipher ParaTime. So currently we have like 43 ParaTime, 43 cipher ParaTime nodes, which makes this network totally decentralized. So we basically don't run any node to be, to manipulate the network, of course. And this scalability, it's very high with our transaction throughput. I mentioned 1,000 transactions per second, and we're also using ROSE as a native token. So you will notice ROSE is used on consensus layer and also on ParaTimes, right? So yeah, cipher ParaTime, it's very interested from a confidentiality and TEE perspective, right? To have a trusted environment. Now, parcel ParaTime, it's, I will not say similar, but in a way, we're calling that some kind of data tokenization, or if you want to say, we want to protect our data, right? Especially if you have sensitive data. We want to ensure, that we have compliant and regulatory environment where we actually control the data, and this data can be encrypted, right? And there's some people, or let's say a developer, or we call them a data manager, who can actually totally control who can access the data or how to access the data, especially if there are some sensitive data or some data that can be used by public users and so on, right? So we have this parcel, let's say data protection built in the ParaTime, so we can guard the data. Now, if we want to analyze this private data, keep in mind that even if you have encrypted data, we can have some encrypted data, and let's say a smart contract, we can just send this to our parcel ParaTime. So basically, let's say to a black box, and then inside this box, right, inside this black box, right, the data will be analyzed, processed, and so on, right? And when the data goes out, the data is encrypted again. So basically, the data is never shown to outside developers or people who are using it, but it's only let's say used inside this black box, processed, and then the result is returned also in encrypted state, right? So we never reveal the raw data, right? And also we provide immutable ledger for any audit, that is maybe necessary, right? So all the transactions that will operate on this sensitive data will be always available and maintained in this ledger, right? Now, I want to go to Emerald ParaTime now, because I want to give you a bit more insights on the EVM compatible blockchain that we built. There are some numbers which are really good compared to Ethereum, maybe other blockchains, right? And I would like to start, for example, with the cost, right? So that's insane, right? What's happening nowadays, if you want to, let's say, mint one NFT or just use some transactions on Ethereum, right? You will bankrupt, right? So it's not even fun to use anymore, right? Me personally, for example, I'm using other chains to have fun with NFTs, with GameFi, with DeFi, and so on, right? Because Ethereum, it's too expensive for me, right? That's why we have these EVM blockchains. And Emerald, it's awesome example of that, right? So we have like 1,000 times lower gas fees or fees, right, than Ethereum. So just to give you an example, you can pay like $10 or $40 versus 2 cents or even less, right? So that's crazy, right? Now we have full EVM compatibility, right? That's why it's EVM compatible ParaTime. And basically anything that you can do on Ethereum, you can do on Emerald ParaTime, right? Now, to integrate, different use cases, such as, DeFi, like DEXs, NFTs, if you're thinking about Web3, right? Crypto gaming, I will give you a demo with Oracle that can give you real-time price back, right? You can do that easily, right? Especially if you're used to, working with Ethereum or Solidity, right? So yeah, scalability, it's pretty much very similar than, with Cypher ParaTime, or, we can actually compare these block times with consensus because it's the same as consensus, right? We're using that. So it's average on 6 seconds. And this is pretty awesome if you're comparing to, Ethereum, because you can just wait average 6 seconds and your transaction is confirmed and you can start working with your, maybe NFT or other transactions, right? Now, currently, Emerald ParaTimes, Emerald ParaTime is run on 56 Oasis node operators, right? And we are using Rose as a native token, so I can actually invite you to our Slack groups, community groups, when we have a lot of good developers and node operators, where we actually contribute and develop stuff, use stuff, and pretty awesome community, I would say. Now, scalability and low cost. I mentioned that, but let's compare some numbers, right? So when we launched our Emerald ParaTime, we actually reached quite, huge or large, high number of transactions per day, right? So when we launched this first DEX, we see a huge boom, right? And that was almost like on Ethereum in the same time frame, right? So we peaked at almost 1 million, right? A bit less, but on average nowadays we had around 200K, right? Transactions per day. Now, of course, there is a lot of room to grow because we're young. EVM blockchain or Emerald ParaTime is young. So we have a lot of use cases coming on from hackathon, from accelerator programs, and from community, right? So it's pretty awesome what we see, how fast we grow, right? And we can see here average block time is the same, 6 seconds, Ethereum 30 seconds. So there is a obvious benefit. And if we just compare throughput, right? Currently we had like almost 7 million transactions per day as a max throughput, but we are thinking about increasing that to more than 10 million per day, right? So this is pretty huge number, but it's always good to be prepared on higher demand, right? Transaction fees minimum is 0.00021 ROS. And currently, probably Rose is around $0.25, so 25 cents. And you can, simply calculate how low fees are there, right? So we used to have 0 fees, but for security reasons, we had to implement some fees. But yeah, on average, typically we find something around 0.01 Rose, which is like 100K, I guess. Now, compared to Ethereum, you see a notable difference, right? It's approximately 1,000 lower than Ethereum fees, right? So, full EVM compatibility. I want to point out that smart contracts are written in Solidity just like on Ethereum or other EVM blockchains, which means that you can simply just move project or create a new project from existing contracts and build on Emerald. So it's very convenient, easy to move to just migrate from any other EVM blockchain or Ethereum to Emerald, because you will find many benefits using Emerald and also Oasis Network. I talked about ecosystem, right? And you will find that huge, right? Now, EVM ParaTime module is based on Sputnik VM, so basically a pure Rust EVM implementation. And guess what? All popular developer tools are available. So I mentioned Hardhat, I mentioned Truffle. I will actually give you a Truffle example, a demo, and Remix IDE, right? So these two are more for serious development, let's say, on your local desktop or laptop, while Remix IDE, it's basically in the browser, so you can start writing or just modifying or using the Solidity contracts in browser and then deploy it to testnet, to mainnet, maybe for some ad hoc solutions or testing and so on, right? Cool. Now, there is actually another way how to develop on the Emerald or basically on EVM blockchains, right? So we will touch the most Truffle. That's just one of the most popular tools out there, right? And basically what you need to do with Truffle is, I would say, two things, right? Just reconfigure the network parameters. So basically there is one file that you will open. I will show you how. You can do it in command line. You can open it with your favorite editor, right? But basically you need to update the parameters. So you can find here Emerald testnet and Emerald mainnet, right? And then you can simply run the Truffle command Truffle test, and then on which network. So basically network Emerald testnet, which means that we will compile and deploy the smart contract inside our, let's say, folders to the testnet in this example, right? So very simple. Let's say you can quickly test and develop, and then you can just try it on testnet. So I will show you how you can do that, right? Then Hardhat, very similar story. If you prefer Hardhat, no worries, it's supported. So yeah, whatever you prefer, right? It's a matter of choice, personal choice, right? So the same as with Truffle, here in Hardhat you have TypeScript file, so hardhat.config.typescript, and you basically provide the network parameters for testnet and for mainnet, right? And then, of course, if you want to deploy a smart contract, you will have to use a command like npx hardhat run blah blah blah, right? On the network Emerald testnet. And this smart contract will be, of course, first compiled and then deployed to testnet, right? So you will notice that it's same as you would develop any DApp on the Ethereum network or any other EVM chain, right? Using Remix, very simple. I will just give you like 5 steps. I will also do the demo, but with Remix, it's a web interface. You can simply provide provide from local or from online source your smart contract, right? Basically a back end of your DApp if you want, right? So smart contract in reality, it's just a back end for your decentralized application, right? So we will provide some code, in our example, simple code to integrate band protocol. And then we will connect one or more accounts. So I will connect one, let's say ETH compatible account, which is used for Emerald. And then I will deploy, I will first, of course, compile my smart contract, and then I will choose inject Web3 because I want to use my own blockchain like Emerald testnet. And then I will deploy that, compiled smart contract to testnet, and I will show you in reality how that looks like on testnet, right? So yeah, that will be done in a demo. So pretty simple steps, right? Now, I want to invite you to very awesome, let's say, new shiny thing in the Oasis development environments, or let's say something very nice for developers. It's actually a local image. So basically it's a Docker image that you can find on Docker Hub. And what you get with this Docker Hub, with this Docker image, is actually one single validator node, right? With 1 second block time. So compare that to the real mainnet if you want. So here is quicker if you want, right? But you also get 3 Oasis compute nodes running ParaTime, Emerald ParaTime, right? So you can see, you can develop, you can test some performance, and then you get also Web3 gateway. So basically that you can connect. So you have some URL where you actually can reach that. So yeah, it's a gateway for EVM blockchain in this case. So for Emerald ParaTime. And you get also helper script, which will populate some initial test accounts for you, right? So I invite you to come test that local image locally on your, let's say, laptop, and give us some feedback, because we're very happy to improve and to give you what you need, right? That's why we're here, right? To start building, where do you go? We have docs.oasis.dev, right? So this is your main source where you will get, parameters to configure. You will get some quick guides. You will have some frequently asked questions. A lot of useful stuff for developers and to start with our network. So what you will usually need is Web3 gateway, right? So this is something that you will find under developer resources, and then you will have Emerald ParaTime and overview, right? So if you will click on Emerald ParaTime, you will basically get this overview, and at the end you will find mainnet and testnet parameters. So that's the most crucial part to configure your network, let's say on your MetaMask, right? So when you will be adding a network, use that parameters to add a new Emerald network. You will find 2 more very useful, let's say, guides. One is writing dApps on Emerald. So I will cover a portion of that, just to give you a bit of taste how easy it is to start with Truffle. And then there's also the whole guide with integrating banned Oracle smart contract, which will give you very simple steps if you want to include some price or let's say pairs like BTC versus USD, ETH versus USDT, these pairs, and if you want to, let's say, include that in your DApp, for example. All right, so I want to also distinguish between two block exports, right? Because people sometimes, they deploy on testnet, but then they are using the mainnet explorer, and then they cannot find their transactions. They don't find the smart contracts and so on, right? So that's why it's so important to use the right block explorer. So there's one on testnet, like testnet explorer emerald.oasis.dev, right? And there is one on mainnet, which is explorer emerald.oasis.dev, right? So use accordingly these explorers, right? And yeah, before I actually go to the demo with Truffle and then later on with Remix, I actually want to invite you to our hackathon that is happening. Actually, it's like 30 days to deadline, right? So you can apply, you can join hackathon. You can go to dev post and you will find our Oasis Bloom Hackathon, right? This Oasis Bloom Hackathon will give you a great chance if you want to start building on our platform, on our ecosystem, because we give you some grants. There are like, I think it's 200K grant in prizes. And yeah, this is split in different categories. And the focus is basically on Emerald and on building dApps for Web3 and even beyond, right? So whatever you have the idea, come show us what you got, and we will be happy to accept you on this program, right? Cool. Now, if you're ready, we can jump into a demo. So I will first show you the developing with Truffle. Keep in mind that I will use some demo, or let's say a short guide that Truffle provides. So basically, it's called a MetaCoin. I think it's a project named for a demo, right? So it's just an example. It's not creating a new coin. It's not our project, but it's just a name for a demo that we will use, right? So first of all, make sure that you have all the dependencies, right? Like npx, npm, right? That you install Truffle on your laptop or on your device, right? And then you can start building, right? So you can open your terminal, and I will just say ls. You will see how many demos I already did. So we have MetaCoin, MetaCoin 2. I will just create another directory. So make directory, and I will say, should we just use MetaCoin like block geeks bg? Okay, what did I do? Oh, mk, it's make dir, right? Okay, now it's better, right? Okay, so let's go to MetaCoin bg. Okay, ls, you see it's empty. Okay, now if you already have Truffle, right, you can start expanding, or you can actually let's say extract the MetaCoin project inside that folder. So I will use npx Truffle and unbox MetaCoin, right? So that's the command that Truffle will unbox this MetaCoin project inside that folder, right? So this is pretty simple, because if I check ls now, what I've got, you will see I have some contracts folder, I have some tests, I have Truffle config.js file. So keep in mind that this Truffle config.js file is the most important file that you will use, because you want to reconfigure your networks. Maybe you want to include some library. It's a configuration file. And then if I go to contracts, just for example, you will notice we have like 3 contracts, right? 3 Solidity contracts. So why I'm doing that? Just because I want to make sure that after we will run some tests, that you will see why there are like 3 compiled contracts and more, right? So, okay, so what I want to do next is actually compile and test the contract type, right? So I will just say npx Truffle test. So this will compile contracts locally, and it will run contracts locally, right? So don't expect that this is running now on Emerald blockchain, because it doesn't. This is locally, right? But when we will configure the JS file, and when we will provide, or we also need to export some variable environment variable to be used, then we can deploy our contracts to testnet, for example. Cool. So currently we have 5 tests successfully performed. Now, in reality, those should be also successful on testnet, but it might happen that some will fail because I will maybe not include some parameters. But yeah, we will see how it works on the real environment, right? On testnet, for example. Cool. Okay. Now, you see these contracts are working now. I want to make sure that I configure my parameters now, right? So first thing I want to do is add, some kind of package that will be used to read private keys stored in environment variable, right? So if I want to add this package, I will say npm. So I will use this package manager, npm I. Then there is a command truffle. You know what? I think I will truffle add truffle slash hd wallet dash provider dash dash save dash dev. This should be a command to, again, to include or to add this package, right? And then we will use it. Okay, so let me see. It should be, yep, cool, it's downloading and it will be included. So yeah, that's what we want, right? So we want to add this package to our project, and we want to use some environment variables later on, right? Okay, now we have this package, and now I can actually do what? I can go actually and change my, change my Truffle config file. Yeah, so you have two ways how to do it. You can say vi, so it depends if you like it or not. So you can say Truffle, so you can actually see what's inside, and you can edit that, this way if you want. Now I'm not really happy using that most of the time, so I will just say X because I want to go out, but I want to use that in my Finder, and I want to open that Truffle config.js file with my favorite, let's say, text editor, right? So I will go to my Finder, I will open my documents and MetaCoin BG project, and Truffle config.js will be opened with my brackets. Cool. Now what you will see, right? I already prepared this network configuration because I don't want to, change and modify everything. So I will just delete that. But essentially, if you want to start from scratch, you can just delete all these commented networks, hosts, and so on, right? You got an idea. But I will just delete that for now because I already prepared some, configurations right here, right? And I will also talk about what's the first row doing here, right? So I will just override this, right? And I will save that. So don't forget to save that. That's important. Now you will notice one, line one, and this is, this is a piece of code to import this HD wallet provider library, right? That we will need to read from that, private key from environment variable. So basically, before we actually add the package, now we're including that library into the config file. And what we also did is to provide network configuration for mainnet and for testnet. You see testnet configuration, mainnet configuration, and the crucial part is that you provide the right URL and that you provide the right, if you want to, use explorers, right? Block explorers, right? So that's basically the most important part. So I saved that, and if I go back to my, command line to my terminal, I can reopen that with VI, and you will see, boom, voila, this file was changed, right? So I just want to make sure that I have the right parameters, right? Now, once I have this package and library included in the config file, and once I entered and modified my network parameters, right, I want to Now run, so before I actually run that on testnet, I want to export my private keys. So make sure that you have two private keys for two ETH compatible accounts that you're using on Emerald or on EVM blockchains. Because this MetaCoin example, right, MetaCoin demo actually requires two addresses, like two private keys, right? So that's why I also prepared, two examples, and I already put them together in the command, which I will use right here. So yeah, keep in mind, you need to say and write export private keys, right? And then you provide the first private key, and then it's split it with a comma. So this comma, it's basically a splitter, right? And then we have another, the second private key, which will be used in our use case. So you have all this documented on our docs. So don't worry, it's there. So you can just, you can copy and paste it like I did, but with your private keys. Okay, so let's export this. Voila. Now, I think I'm ready to compile and deploy that to my testnet now. So let's do the Truffle test, and let's do -- network. So I need to provide a network destination or name, and my network destination will be Emerald _ local. So why Emerald _ local? Because that's the name in my config file, right? So however you will name your network, well, use that as a name right here, right? So let me try that. Now, keep in mind that this will not, okay, you must specify network ID. Okay, probably I forgot something. I did a typo. It's Emerald. Oh, Emerald local. Okay, give me a second. I think let's check this one. Module exports. Okay, networks Emerald. All right. So did I miss something or? It's usually like that. Don't worry. So that's how the demos work. Yeah. So okay, it's easier packages environment. Okay. Let me check. So let me go once again in VI. Did I forget something or? Okay, I have this one. Okay. Module exports, I have a double colon here. Okay, let's go out. So what object method network config, Truffle test, Emerald local. Your network specific ID in your Emerald local configuration. Okay, where did I? Networks. Okay. You know what? Let me find my first example, because I might miss something, right? But I think this should be the same, right? Yeah. Okay. Okay, let me try once again. Some troubleshooting. Nope. So okay, object detected, packages, environment. Okay. Node modules. Okay. Okay, let me check what could be wrong then. Okay, vi return. I have Emerald. Okay, Emerald mainnet, Emerald testnet. Okay, that should be okay. Okay, Emerald, not local, but testnet. Yeah, that would, yeah, that makes sense, right? Because I didn't call my network local, but it was my Emerald testnet, right? Gasper, right? Okay, so yeah, that makes sense, right? Now, what you will notice, it will take a bit longer, right? So it takes a minute or two or so, because now the contracts will be compiled, as you've seen, right? And then we will be actually deploying that on testnet, right? So that's why we have here Emerald testnet network, right? Emerald testnet network. And once these contracts will be deployed on testnet, some tests will be performed. Just like if you remember locally when we set npx truffle test, now this will be done on testnet, right? So that's something that it gives you a real world experience, and that's why it takes a bit longer, right? So it's not with 1 second average block time, but it's 6 seconds and so on, right? So currently this is happening on testnet in real life, right? And keep in mind that testnet will equal to mainnet, right? So when you will be deploying that to mainnet, the same thing will happen, right? So a few more seconds will be used to deploy and test these contracts, right? Maybe one more thing to add here. Now, it depends what you prefer. You can use local image from Docker Hub and test this much faster, and and develop much faster. But still, the real experience and testing the the network is actually using our testnet, right? So that's why I always say, okay, you can develop locally, but then let's deploy to testnet and see how that works in reality, right? Now, awesome. There are two tests done. Test Metacoin. Cool. We have 3 more tests, but as far as I'm concerned, I think that 2 will, maybe just 1 or 2 fail. Should send coin correctly after each hook after test. Yeah, so maybe there was 1 parameter that I missed or so, but essentially, see, we have 4 green check marks, which makes that pretty cool stuff going on the testnet. Okay, so that's the end of my first demo, and let's jump now to the second demo, right? So that was Truffle. Now, that will be a demo with Remix. It will be integrating Band Oracle Smart Contract, and I want to show you how easy it is to integrate using our template and Band example, right? So what I will do, I will just use our docs. So go to docs.oasis.dev. You will land to this docs page, right? And if you scroll down below, you will find developer resources, right? So keep in mind that you are looking at the Emerald ParaTime. So if you click on that Emerald ParaTime, you will find these Web3 gateway parameters, testnet, and so on, right? This is something that you will try to use during your development. And then you go to integrating Band Smart Contract example, right? So the first link will actually, redirect you to the remix, right? And what you will notice is my smart contract, which is already there, that you can maybe edit or reconfigure, right? But you see, it's a bit older version of Solidity, but that's how you will have to choose from the compiler drop-down menu, right? So make sure that you have the right version. So it's 0.6.11, and then you can see a smart contract, right? So the most crucial part here is if you will be using the Oracle example. First of all, you will see the contract here, right? So contract demo Oracle. Demo Oracle is the name of this smart contract that will be deployed. I can call it demo Oracle, BlogX BG, or just demo Oracle BG, whatever, right? And then you can actually change the base and quote. Like base, it's, let's say, rep BTC versus USD, right? So you have this pair and it's called base versus quote, right? And now this will be performed once a developer or user will click, for example, get price function. There is also another function, get multiple prices, right? So when this will be pressed, I will get rep BTC versus USD. I will get ETH versus USD, right? You could add, multiple symbols here, like, rows versus USD, rows versus BTC, right? But yeah, for the demo purpose, I will just use, this smart contract, and I will compile that contract first, right? So let's compile that. I click compile, so that's fine. Now I'll go to Solidity deploy and run transactions. Keep in mind that I want to use injected Web3 because I will use my second, the network on the Emerald testnet. So connect your MetaMask. So I'm using my second demo account, but essentially you can connect multiple accounts here. So I will use the one that I will, create and deploy a smart contract, this band smart contract. And then I have to provide, so you can provide it right here, address reference. It's basically an Oracle address that is used to return the prices, right? So essentially you see there is a ref. This is the constructor. So I will go to my guide back again, and I will just find the Emerald testnet band reference data aggregator, right? So this is the address of the testnet band reference data aggregator that I'm using right here, right? So I will paste it here. And now, since I have smart contract ready and I choose the right parameters, I can click deploy. And I want to show you down below. Okay, so of course you will have to confirm that because we will deploy that and test our tokens on our testnet. In reality, this will be rows, but I will confirm the transaction and I will just extend this a bit. So you will see my transaction. You see the transaction was successfully made on the testnet, and if I click, for example, transaction hash or from, so let's say I will click from, right? From, it's just my address I used to actually deploy the smart contract. So I will just click on that. You will notice the balance is the same, right? And voila, 30 seconds ago, or almost 1 minute ago, this smart contract was created, right? So this is the transaction hash, and you can see all the details right here, right? So yeah, now we have smart contract on the chain, on testnet, right? What we can do now is actually test all these functions. So get price, get multiple prices. In reality, of course, you will use that in a different way, but since we're using Remix, there is an option to actually expand down below these functions. And if I click get price, you will notice down below in the transactions section, just give me a second. So that was a call, right? Now we have a function call, or let's say, this call was actually also on chain. And you see from which address, what was the, input and so on, right? But the point is that you actually get, Bitcoin or wrapped Bitcoin price multiplied by 1 on exponential 18, right? So if you just remove 18 zeros, you will get the actual price, right? So you have this explained in the guide, right? Pretty cool, right? Now, get multiple prices will actually give you, we have wrapped BTC and ETH versus USD, right? And that's exactly what you will see here, right? But of course, with multiplied, basically 10 on 18, right? Okay, so that basically concludes my demos, which is pretty cool. You see how easy and awesome and fast it is developing with the remix. Same for the Truffle, right? And yeah, I'm happy to give you that knowledge and come back for more, because this is not the last video we made. And I invite you again to our hackathon, and let's see you in the next one. Thank you.